Let's now talk about the concept of average velocity. Average velocity is found by taking a quantity which is known as displacement divided by time. Now, what's the difference between displacement and distance? Remember, to find average speed, we took the distance and divided by the time. For average velocity, we take something called the displacement and divided it by time. Well, displacement is really defined as the change in position between two places. So for example, let's say that this is the 0 meter position, and over here is the 1 meter position. So the displacement is 1 meter, and then we need to tag on a direction. So since to the left is negative, we would say that this vehicle is displaced -1 meters. Its distance is 1 meter. Let's take a look at another example. Suppose this vehicle drives 1 meter and then comes back a half meter and then drives an additional half meter like that. So what distance did it drive? Well, 1 meter plus a half meter plus an additional half meter. So that's 2 meters. But what was its displacement? Wouldn't its displacement still be 1 meter to the left, or -1 meter? So you see there's a difference between displacement and distance. Let's do another one. Let's say it starts here, the vehicle. And let's say it drives a half meter. And then let's say it goes back to there, where it started from. Okay? So what distance did it drive? 1 meter. What is its displacement? Isn't it 0 meters because it ended up where it started? Let's do another one. Let's say the vehicle starts here. Okay? So this is at the half meter position relative to the 0 meter position here, the half meter. And it's to the right, so it's positive. So that's where it starts. Let's say the vehicle goes to here, so that's a half meter to the right, and then it comes back to here and stops. What distance did it travel? Half meter plus a meter, so it went 1.5 meters. What's its displacement? Well, it started here and it ended up here. So wasn't it displaced a -0.5 meter, where the negative means it was displaced to the left? So to find average velocity, you take the displacement and divide it by the time. Velocity is what we call a vector quantity. It has both a magnitude and a direction. Because you'll notice in our last example, for example, the displacement was -0.5 meter. If that took 1 second, then we would say its average velocity is -0.5 meters per second. So the negative sign here gives the direction. If I ask for average speed, in this case, well, it would have been, it started here, it went here, that's a half meter, and then it went all the way back to here. Okay, so that's a half meter plus 1 meter, so 1.5 meters is what distance it traveled in a time of 1 second. So the average speed would be 1.5 meters per second. No direction, okay, just 1.5 meters per second. Whereas the average velocity for that last example there is -0.5 meters per second. Okay? Let's take a look at another example involving velocity. Okay, I fully wound this toy so that it travels at pretty much a constant speed, at least for a while. Okay, so let me put it on the track here. There we go. Okay, constant speed. How can we figure out its speed? Well, we would have to take the distance it traveled and divide it by the time. Okay, so let's figure out the distance around this track first. Okay, so let me get a meter stick. And we'll just approximate here. Let's just say it's a meter. Okay, close enough. Good enough for government work, as they say. All right, so the circumference of this circle, okay, which it is, C, is equal to 2 pi times the radius, 4 pi d. And I said that the diameter was approximately 1 meter. So we're talking about a distance of about 3.14 meters. So let's time it, and then we'll get the average speed. So it'll be fully winded again. Okay, here we go. Here we go, ready, set, go. Okay, so I got 6 seconds, 6 seconds. So the average speed distance over time. So 3.14 meters divided by 6 seconds. So we're talking about 0.5 meters per second is the average speed. How about its average velocity? Let me wind it up again. So that it has the same average speed. But now, I want you to figure out the average velocity of this toy going once around the track. Okay, so here we go. Okay, so why don't you hit the pause button and see if you can figure out the average velocity of this toy going once around the track. And when you figure it out, come back and we'll check your solution. So what did you get? Well, I hope you got 0 meters per second for the average velocity, right? I said once around the circle. So that means it ended up where it started from. So it was displaced 0 meters. So the average velocity is 0 meters per second, whereas the average speed, 0.5 meters per second. All right? Now, before I let you go, let's talk a little bit about constant velocity and changing velocity. Let's just go back to this. Okay, as this toy goes around the track, it might have the same speed at every moment, right? But isn't its direction changing at every moment? Like for example, here it's going to your right. Here it's coming towards you. Here it's going to your left. Here it's going away from you. And here it's going to your right again. So as this goes around, isn't its velocity changing? So even though the speed is always the same, what was it, 0.5 meters per second, its direction is always changing. So we would say this has a changing velocity. In order for something to have a constant velocity, neither its speed nor its direction can change. For a changing velocity, you need to have the direction change, or you could have the same direction all the time and the speed changing. Okay, so for example, that if you remember that car that I used the other day, this is traveling in the same direction all the time, but its velocity does undergo a change when it speeds up. Okay, so a changing velocity involves either a constant speed, changing direction, like this toy, or a constant direction, changing speed. And of course, I guess you could have both. Makes me think of a roller coaster.